What's up there, YouTube? It's been a while since I've done a video. I figured I would touch base with everybody, see how you're all doing, and give you a little bit of an update on what I got going on here. I made a pretty big improvement, I think is an improvement. What I had done was, I'm actually still using the two inverters. Now I have them in series. I'm sorry, parallel, as you can see here. And I recently purchased this from windandsunpower.com. It's their 12 24 volt relay, universal relay dump controller. And I'm also running 4 of my Windy Nation 100 watt solar panels in series parallel to get 24 volts. Let's see here. So the big significant change that I had done was, instead of going 100% grid tied, I'm actually running a little bit of what I call a hybrid system. I found a great deal on some batteries that I just couldn't pass up, and I wanted to incorporate them into the system somehow, and I figured this was the best way to do it. So I'll just go over the system really quick. Now just pardon the mess, because I'm actually in the process of trying a couple different things to see what I like and what works better. So as you know, I got the 3-phase number 6 wire coming, number 8 wire coming down off the Windy Nation on the roof, right into 150 amp rated full wave bridge rectifier, 3-phase bridge rectifier. It comes into that and then comes out of the positive and negative sides of that, and that's actually where I have the solar panels connected. You can see the positive side of the solar panel comes in here and goes into a 75 amp blocking diode, which is going through this heatsink that I was able to get my hands on. I have the rectifier connected to it and this diode, so the positive side is actually hot on that bridge, or that what am I trying to say here? The heatsink. Jesus, what the hell's wrong with me there? But this heatsink I was able to get my hands on from my job. They actually had these old irrigation system controllers, and this was part of it. All the, I guess the MOSFETs or voltage regulators or whatever, what they were connected to it. It was for them. You can see there's 2 screw holes in this. There's one here and there's one underneath that terminal. But I just drilled a hole in the center. Sorry about that, camera died. Anyway, so yeah, I just drilled a hole and I mounted the diode to it here. And then the positive comes out of the diode into, well, not into, but connecting to the positive side of the bridge rectifier, which then comes down, connects here, and then we'll continue with this section here because everything else is kind of a little bit scrambled. Then the negative side, I did the same thing. Negative side of the solar panel comes in. I'm using the same number 6 wire for the solar. I know it's not solar rated wire, but it's heavy wire and it works really well for this. And plus I got a whole spool of it right here. So negative side comes in here, comes down, terminates here. Now I got these 2 little fans running. I bought 4 of these on eBay. One of them I actually have here, and there's 2 of them up behind there. There's one there that's the one that's actually on, and it runs on solar only. So when it gets dark, it turns off. And then that one over there, that one's not hooked up right now. I want to get a snap disc, a thermo disc, so it comes on only when the heatsink heats up. Because actually, when I didn't have a heatsink on there, it really didn't get all that hot anyway. But just as an added, I guess, feature, just to kind of keep the heatsink cool, keep the diode cool. Electronics do not like heat. So wind and solar are tied together, but separated with diodes. Okay, so once they come into here, positive and negative actually come back into this old box. I actually repurposed this box. I'm actually thinking of taking it out of the system completely and using a smaller setup, but I'm not sure yet. So the positive actually comes down here into the 70 amp breaker and then is directly connected to these. I'll get into these a little bit more. Positive side is there, and then going through that bolt, positive and negative come in. Negative comes down from here, and this is actually where the 75 millivolt 100 amp shunt is. So it comes in the top, goes out the bottom, and then comes back out here, and this goes down to the battery bank as well. And then this side here actually goes directly over to... Sorry, camera keeps crapping out on me. Anyway, power. What was I talking about now? I completely forgot. Okay, so the system is always connected to the battery bank no matter what happens. Unless this breaker trips, this wind and solar system is always going to be connected to the battery bank. Now, the output side of this block actually goes down to the battery bank, and the negative side goes over to the grid tie, and the positive side goes over to the grid tie. The negative is always connected to the grid tie inverters, the battery bank, the solar panels, and the wind turbines negative. Positive side now, on the other hand, comes in on the top side, which is this lead here, comes in through the top bolt. Okay, and then I have my voltmeter sensing circuit, the shunt meter wires here, they're both exactly the same length. Let's see, what else do we got here? These two here, these don't do anything anymore. These actually went to that solenoid back there. But right now I don't have them connected. But let's see, it's very simple, but it's a mess. I'm kind of trying things out. But the power comes in from the battery bank and the wind and solar panels through this solid state relay. It's a 40 amp relay, rated anyway. And then what'll happen is it'll close the circuit and it'll go out the top line and then go out the bottom bolt, which connects the battery bank, wind turbine, and solar panels to both grid tie inverters. And this one here is 10 to 30 volts, and this is 22 to 60. 500 watts, 1000 watts. And I also have one of them little fans on the heatsink in order to keep that cool. The head heatsink is actually a little undersized for that solid state relay, but it works. It's working. I've never had it get hot. It doesn't get overheated. No problems. And there's my voltmeter, ammeter, and then you can see here with the wind and sun power, I have this actually calibrated for these batteries based on the data sheet that I got from Exide directly. The battery bank is an Exide battery bank, but this is my float voltage. It's 26.6 volts, and that's my current battery pack voltage. And then I have 4 wires coming out of here. These 2 wires go right to the battery bank. These 2 wires go to the solid state relay. So down to the battery bank. Right now I just have it clipped on the sensing circuit for the universal dump controller. But these are Exide 6-volt batteries. They're floor scrubber batteries. They're about 2 feet tall. Maybe 18 inches. Let me see. Let me get a lot of crap in the garage. Still going through some shit. But let's see. We got a little over 15 inches tall, and then they're the standard width and depth. This is the standard about 7 1/16 of an inch deep or wide by 11 and let's call it 11 and a half deep. So the only thing different is the height. But these are rated based on the data sheet, I believe, at 160 amp hours. Or 160 or 215 minutes reserve power. I forget exactly. I'm going to have to double check the spec sheet. I got it on the computer. But I got 4 of them. I got them for a steal. I'm going to get 4 more so I can do a series parallel 24 volt pack. And then that way I'll have a nice battery bank to start off with. And that probably won't go much bigger until I really get into get into the inverter side of things. But that's the quick update. Everything is 4-gauge wire, homemade terminals, homemade ends, I should say. Everything's pretty good. I actually just checked the water in them today. That's why you see a little bit of acid all over the place, because I'm actually overcharging them a little bit just to equalize them. And then what I'm going to do is I'm actually going to disconnect the pack, run it in 6 volts, and set it up in a completely parallel configuration. So it's just one big 6-volt battery pack, in order to get the battery voltage exactly the same in each battery. And it's going to have to sit that way for a few weeks in order to fully equalize, because I believe this battery here has like a 0.5 volt more than this one, and this one's got 2.2 volts more than this one, and they're all a little bit all over the place, so I got to get them equalized. But yeah, that's my latest update there. You noticed I took away the voltage regulator. That's no longer in there. I actually redid the entire electrical system in here until I got these batteries. If I have the video of that, I'll see if I can post that too, where I was still operating on the mechanical relay, but that thing is so damn loud, it's just no fun to use, because all you hear is click, 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 and you could hear it in the house. It's that loud. But I got that from Thermodyne. That's a really nice, solid built, whatchamacallit, solenoid. It's a double pole, double throw. These contacts are normally closed. These are normally open. Or no, I'm sorry, these are normally closed and these are normally open until it activates, and then these are open and then these are closed, the top ones. But right now, yeah, that's it. That's all I really have to show you right now. Once I get everything cleaned up to where it looks good, then we'll get everything a little bit more mounted. And like I said, I'm going to change that fan so it only runs when it gets hot. And same with that one there. That one will run when it gets hot. But I actually have a diode on this fan, because when it spins down, it actually kind of keeps the relay turned on. And I actually was having a little bit of problems there, so I put that little diode in there to rectify that problem. But alright YouTube, that's it for now. I just wanted to give you a quick update on what was going on. I know it's been a long time since I did a video, and I'm hoping to get a few more up as the system progresses a little more. But you know, shoot me a comment, questions, concerns, subscribe, like, favorite, all that crap if you want. If not, whatever. Enjoy. Okay, thanks.